Okay, I believe I am recording. Here we are in Desmos. We just finished talking about linear functions and did a few application examples. We're going to head back now to chapter 3. Take a look at section 3.5, which teaches us some stuff about transformations. We're going to look at a function here as an example, and I'm going to use the square root of x function. So remember, here the graph of this function shows points where the y value is the square root of the x value, right? So input x and output square root of x, input x, output y. For example, 4, 2 is on this graph because 2 is the square root of 4. So I'm going to take this graph and we're going to do some transformations to it. First of all, I'm here on this line, I've defined f of x equals the square root of x, and Desmos assumes that you mean you want to graph that. That's what you usually do in Desmos. But another way to think about that is having defined f of x as a rule of assignment, we could then write, let's have y equal f of x. And then that relationship is what kind of defines the graph of this function. And writing it this way, what I can do is I can do things like add stuff there, or I can add stuff here, and see that the effect is a little bit different. Okay, so this is where I have to explain that y and f of x are not exactly the same thing. I know I have said that a lot of times they're interchangeable, but I did warn you kind of upfront that they're not exactly the same. And this is a situation where it's kind of important to see that they're not the same. I mean, just to demonstrate that they're not the same, notice that if I have y equals f of x, if I add 2 to the right side of this equation, that takes the function and it seems to move it up, right? If I were to add 2 to the left side of this equation, that takes the function and it moves it down. So adding 2 to f of x versus adding 2 to y has a different impact on the solutions of the equation, and therefore y and f of x must not be exactly the same thing. So that's what's going on here. What they are is that y represents a coordinate on the graph, whereas f of x represents a rule of assignment. F of x is interchangeable with square root of x. That's really the right way to think about it. So this is about transformations. Let's start with talking about shifts. So a shift is what you just saw. A shift is something moves up and down or left and right. So what's going on here is if we want to take the whole graph and move it down 2 units, as you see we've done here, what we need to do is we need to add 2 to the y variable. The y variable that represents the y coordinates, like that. You're not really adding 2 to the coordinate. When you add 2 to the y variable, what it's doing is saying whatever y coordinate is, whatever that y coordinate is, add 2 to it before you use it in this function or use it in this equation here. Right? So if we want y plus 2 to equal f of x, then what we're saying is not that the y coordinates are the square root of the x coordinates, but that if you were to add 2 to those y coordinates, you would get the square root of the x coordinates. That's why we have the point 4, 0. It's not 0 is the square root of 4 any longer. It's that if you were to add 2 to 0, you would get the square root of 4. All right, that's how to read this. So in fact, what ends up happening is when you add 2, you shift down. That means if you subtract 2 from y, you shift up, right? So this is, I think, I forgot until this moment. I've actually already explained this back when we were looking at circles and ellipses. So this is what's going on. It's the same idea that I explained before, which means if I subtract something from the x coordinate, or from the x variable, if I subtract 2 from x, it doesn't shift left, it shifts right. If I subtract negative 2, then what it does is it shifts to the left. And that's the same, subtracting negative 2, that's the same as adding 2. So there we go. So that's basically how vertical and horizontal shifts work. The only difference is that whereas for x, we talk about subtracting 2 from the coordinate, when dealing with functions, instead of talking about subtracting 2 from y to shift it up, we actually usually take this and move it to the right-hand side of the equation. So add that 2 to both sides, put it over there, and now to shift the function graph up, we actually add 2 on the outside of the function, right? This is how you will see it most often, but I want you to think of that as on the other side of the equation, it would have subtracted from y, because that makes sense, right? At least it makes it the same, makes more sense in that it's the same as the way as how it works for x. So that's shifting. Now, scaling is where you, instead of adding, you multiply. So again, we did this with with ellipses. If you multiply x by 2, then what actually happens is the entire graph is going to get smaller in the x direction. It's gonna, all the x values are gonna get cut in half. When you multiply x by 2, you actually scale horizontally by a factor of 1/2. So the original graph had the point 4, 2 on it, right? I multiply this by 2. I no longer have that. Instead, the point I have, I can get it by taking the x coordinate and dividing it in half. So that's going to be 2, 2. That point is on the line. My original graph had the point like 9, 3. Square root of 9 is 3. Let's check out the original graph. There it is. All right. If you multiply by 2, instead of 9, 3, we're going to have the point 9 divided by 2. 4.5, 3. There it is. That point is on the graph. So we see here, we see really what's happening is everything is getting cut in half in the horizontal direction. Okay. So that's what happens if you multiply by 2. If you divide by 2 or multiply by 1/2, so 0.5 in here, then instead of shifting, instead of stretching, like instead of shrinking it down, it stretches it out, doubles all the x coordinates. So if you do it with y, say you multiply y by 2, like that's now sort of taking the idea from the horizontal stretching and shifting and compressing, move that to vertical, and we can see that what's happening here when we multiply y by 2, we're actually cutting all the y coordinates in half. So let's put that 4, 2 back up there. If I were to multiply y by 2, instead of 4, 2, what we have now is take the y coordinate and cut it in half, and we have 4, 1. So you can see that the y coordinates are getting cut in half there. That's what's happening. Usually it's not written like this. Usually, instead of having the multiplying by 2 on the left side of the equation, you divide, you should move it over to the other side, you divide, and instead you have a times 1/2 on the right side of the equation. So if you see a multiplier that's outside of the function, then you're actually going to scale vertically by that exact factor, not the reciprocal of it, by that factor. And the reason is because it's already been moved from the left side where y is over to the right side where your f of x is. So that's how scaling works for functions like that. Okay. So the last thing to talk about is reflecting. So reflecting is like flipping it over an axis, and you do that by multiplying by a negative. If we replace x with negative x, what that does is it takes all of the x values and makes them negative. At this point, 4, 2, we're going to follow that over to negative 4, 2. There we go, and now that's you arrive at. So this has the effect of reflecting it over the y-axis, okay, taking all the x's and swapping their sign. So positives becomes negatives, and if there were any negatives, they would have become positive. That's what happens when you multiply x by -1. If you multiply y by -1, then, you guessed it, all the y coordinates become negative, or they swap signs. They get multiplied by -1, and you reflect over the x-axis. So, as always, instead of actually writing that on the left side of the equation, with functions, we often like to move that to the other side, which is just putting the negative on the other side of the equation. Seeing a negative outside the function means that you've done that reflection. So there's explanations. I'll sum all this up in another video in a few minutes. Oh, how do I stop? I stop like